All right, today we are starting a very exciting part of our pre-calculus course, which is trigonometry. And for most of you, if not all of you in here, this is going to be a pretty new concept for you. And trigonometry in general is basically built on angles and triangles. And so what we're going to see here, even in this first lesson, is how important understanding angles are. And so what we need to do today is we need to learn how to convert angles from degrees to two other types of angle measurements. And the first being an angle measurement called DMS, degree, minutes, seconds. And that's what the letters stand for. And a lot of times people who are flying planes or whatnot, boats, they will describe their angle or their location using this different angle measurement system called DMS, degree, minutes, seconds. And so the first thing that you want to pay attention to here is that each degree is subdivided into 60 minutes. All right, and so the way I memorize that is there's a show that comes on Sunday night. It's called 60 Minutes, and that's the way I remember that. So 60 minutes, and it's not necessarily connected with time like you would think minutes and seconds as far as time, but this is how they describe the angle. 60 minutes is 1 degree. And then, of course, 60 seconds is in 1 minute. All right, so what we want to work on in this first example is we want to convert 37.425 degrees into degrees, minutes, seconds. All right, so the first thing that we recognize here is that we already have 37 degrees. All right, we already have 37 degrees. So we can go ahead and write that in our answer. So it's going to be 37 degrees. All right, and now we need minutes and seconds. So what you do is you take the rest of this, which is 0.425 degrees, and you convert that into minutes and then seconds. All right, so let's say we take 0.425 degrees, and we want to convert that, so we need to multiply by a conversion factor. So that's going to be, once again, 1 degree, and that's going to be equal to 60 minutes. And let's see what we get there. And we end up getting 25.5 degrees, 25.5 minutes. Now we want to think, okay, how many whole minutes do we have? We have 25 whole minutes. So that is going to go in the second part of our answer, 25 minutes. And by the way, minutes you denote by using 1 apostrophe, and seconds we'll use 2 apostrophes. So similar to what we did before, you're going to focus in on the decimal portion. So we've got 25 full minutes, and we still have 0.5 minutes left. So if you take that 0.5 minutes and you further convert that into seconds, well, we know that 1 minute has 60 seconds. And so that's going to end up giving us 30 seconds. All right, so we're going to put that on our answer, and we're going to use 2 apostrophes to denote that, and that is our final answer. We have converted into DMS. This is the degree, this is the minutes, and this is the seconds. All right, now in this next example, we want to actually go backwards. We have 42 degrees, 24 minutes, and 36 seconds. We want to convert that back to a basic measurement of degrees. So what we do here is we take the 42 degrees and we say, okay, well, I know I've got that, so I'm going to leave that in its place, and I'm going to add to that what I get after I convert 24 minutes and 36 seconds to degrees. So over here, maybe we will convert 24 minutes. So we'll say 24 minutes. And as we said, 60 minutes, just like the TV show, so 60 minutes and 1 degree. All right, and so when we cancel the degrees, or excuse me, the minutes out, we will get 0.6 degrees. All right, and so now we need to actually convert 36 seconds into degrees. And so now we have, maybe we'll do that in red here. So we have 36 seconds. Now first you must convert that to minutes. So you have to say, okay, well there are 60 seconds in 1 minute. And then we will say there is 60 minutes in 1 degree. So this is basically just unit conversion is all it is today. So you end up getting 36, so actually the seconds will cancel and the minutes will cancel, and you end up getting an answer in degrees. And that answer is going to be 0.01 degrees. So once again, if you go back to what we started with, you have 42 degrees plus 0.6 degrees plus 0.01 degrees, and you add all of that up and you will get 42.61 degrees. And now we have converted from DMS back to a simple measurement in degrees. So this is pretty straightforward going forward and backwards. All right, now we're going to talk about the more common way of measuring an angle with the exception of degrees. And this is extremely important, so you want to pay very close attention here. The most common way of measuring an angle outside of simply degrees is in radians. And particularly when you go into calculus, everything we do is in terms of radians, all right? And so let's first focus on what a radian is. A radian is nothing more than 1 radian is the angle that you have when the side of this angle, so we'll say the radius, is the same length as the arc. All right, it's the same length as the arc. So you notice here that the arc has a length of A and the radius also has a length of A. When that is true, you get an angle. It's a special type of angle, and it is called 1 radian. And you can figure out what that is. It's going to end up being 57 degrees or so, somewhere around there. But let's see if we can learn how to convert back and forth. The key that you want to understand here is that pi radians, all right, pi radians is equal to 180 degrees. All right, and that's just a unit conversion. That's just like saying 5,280 feet are in 1 mile, or you could say 12 inches is in 1 foot. You could say 1,000 meters is 1 kilometer. It's just a unit conversion. So just the same way that you would convert units in any other problem is how you would use this. All right, so let's say I give you an angle, let's say 20 degrees. And we want to convert 20 degrees into an angle in radians. Well, once again, you would start with 20 degrees and you would multiply by the conversion factor. So what is the conversion factor? Well, pi radians is equal to 180 degrees. So you would want to get the units to cancel. So therefore, if degrees is on the top, which it is, you want degrees to be on the bottom. So you're going to put 180 degrees here and pi radians up here. And this way the degrees cancel, and what you're left with is 20 pi over 180. And what are the units that are left? Radians. And certainly you want to reduce that, and your final answer after you reduce it is going to be pi over 9 radians. Now, that makes sense because, once again, when you're dealing with an angle, I want you to think of pi, once again, as 180 degrees. I know you're used to thinking pi as 3.14, and that is the value of the symbol pi, but a pi in terms of radians is going to be 180 degrees. And so you can always check your answer, because if you take this pi and you just make it 180 degrees, divide by 9, what do you get? You get 20 degrees, which is the same thing that we started with. All right, so we're going to do a couple examples now in the notes. All right, so these two examples should be pretty simple, as long as we keep in mind that, once again, pi radians is equal to 180 degrees. All right, and so the first one, we are converting from degrees to radians. So we want to start with 90 degrees. So we'll say 90 degrees, and I'm going to write out the word degrees, at least the 3 letters, times a conversion factor. So we need 180 degrees to go down here, and we need pi radians to go here. And we're going to cancel off the degrees, and we end up getting an answer which is pi over 2. When you divide 90 by 180, you get 1/2, so pi over 2 radians. And that is the answer. All right, so then in letter B, so this was letter A. In letter B, we're going backwards. So now we're starting with pi over 3 radians. So let's say we have pi over 3 radians, and we want to convert that to degrees. Well, this time, now notice we need radians to be on the bottom. So this time we need to put pi radians on the bottom, and on the top we need our 180 degrees, because that's what we're trying to convert to. And once again, this time the word radians cancels and the pi cancels. Now be careful, the pi is not always going to cancel. All right, and sometimes students will think that every time you have an angle in radians, it must have a pi. Be careful, pay attention, pay attention, pay attention, pay attention that it will not always have a pi in it. All right, so I'll do an example of that next. But here, what we see here is we end up with 180 over 3, which is going to be 60 degrees. So now every time you think of pi over 3 radians, you're going to think of 60 degrees. Once again, I know this is not on our notes, but we'll just throw another example in here. I could say convert 4 radians into degrees. If that's the case, then once again, you're going to have pi radians down here and 180 degrees here. Now in this case, the radians are going to cancel, but the pi is not, because there's not a pi on the top. So in this case, you're going to end up having 720 over pi degrees. And you can actually use a calculator and divide that, and you'll get some sort of decimal, and that's going to be the angle. All right. All right, the next concept we're going to cover in this video is a concept called arc length. And you should be somewhat familiar with arc length. Basically, arc length is really nothing more than a part of the circumference of a circle. So let's say you have a circle, not a good circle, but you get the point. Well, arc length would simply be, we know the circumference would be the distance all the way around that circle. Arc length would simply be, let's just say, the distance of just maybe a portion or an arc of that circle. All right, and so what we want to do is we want to figure out how to compute the length of an arc, which is called arc length. All right, now you have two formulas here. The first formula, and it's very important to understand, the first formula is the formula if the angle that we give you is in radians. All right, and if the angle we give you is in radians, then you need to use that formula right there. It's the easiest one. All right, it's simply S, which is the arc length, is equal to R, which is the radius of the circle, times theta, and theta is measured in radians. If we give you the angle in terms of degrees, then you need to use this formula below. Pi times r times theta, which may be, let's say, 20 degrees or 30 degrees or 40 degrees, divided by 180. All right? So let's apply this to this first problem here, the perimeter of a pizza slice. All right, the perimeter. The key word here is perimeter. Every year, have students that will miss this problem because they don't read through it. All right, so find the perimeter of a 60-degree slice of pizza. All right, so at the risk of making you hungry, all right, we're going to draw a pizza, or at least one slice of the pizza. All right, and what we have is an angle, which is going to be 60 degrees. So we'll throw that angle in there. And we have a radius of 7 inches. So if that's 7, that's also going to be 7 there. So the question mark is, what is the arc length? Well, the angle is given to us in degrees, so we should use the bottom formula. All right, so what is that formula? Well, S is equal to pi times r, and r is 7, theta, which is 60, divided by 180. And we work through that, and that is going to end up being, after we work it through, 7.33 inches. And a lot of students will circle that answer because they've done so much work and they're thinking that they're done with the problem, but we have to go back and remember that it's asking you for the entire perimeter of the pizza. So you just found the arc length, so you need to add 14 to your answer because you have two sides of the pizza you have not accounted for. So you have the 14 plus the 7.33, and that's going to be 21.33 inches, and that is your perimeter. All right, this last problem is really nothing more than a unit conversion problem. That's basically all it is. And so what we want to do is we want to take the speed of a truck, which is currently given as 630 revolutions per minute, but nobody really describes their speed as revolutions per minute. It's normally miles per hour. So we want to convert that, all right? And so we're going to start with 630 revolutions per minute. Now, don't put RPMs, put revolutions per minute. That way you know which unit goes on the top and which units go on the bottom. So all we're going to do is we're going to just convert all the way across into miles per hour. Doesn't matter the order, as long as at the end miles is on the top and hours is on the bottom. So first, maybe I will convert the time component from minutes to hours. So if I do that, we know that there's going to be 60 minutes in 1 hour. And hey, that is done. Because what did we want? We wanted hours to be on the bottom, and we've already accomplished that. So now we need to get miles on the top. All right, so the key to this problem is right here. Understanding that 1 revolution of a wheel is equal to the circumference. And we know the circumference is 2 pi r, or pi times diameter. We learned that a long time ago. All right, so that's the key. So if you're trying to convert revolutions into circumference, all right, or some sort of unit measurement like inches or whatnot, you need to use this conversion right here. 1 revolution is equal to the circumference. All right, so let's see if we can do that. 1 revolution is equal to the circumference. Well, what is the circumference? Pi times the diameter. What is the diameter? It tells us the diameter is 36 inches. So therefore, this is going to be 36 pi inches. Now don't forget to put the units there or you'll get confused. Inches. All right, so we're doing good. All right, so now we can see that the revolutions will cancel. And now we just need to convert inches to miles, and we are home free. All right, so we have 12 inches is in 1 foot. And then we have to remember that 5,280 feet is in 1 mile. And all you need to really do at this point is multiply everything, so you cross off your units. Inches goes away, feet goes away, and you end up with 67.47 miles per hour. Now, please do me this favor. Always make sure that your answers make logical sense. Okay, this is a truck. It's not a plane. So if you get some sort of answer like 6,294 miles per hour, you know you did the problem wrong because cars do not go that fast. So always do a reasonable check before you write your final answer down. All right, now on the homework, you're also going to have to go backwards, where we give you something in terms of miles per hour or miles per minute or something, and you have to go backward to revolutions per minute or revolutions per second. But the key is remembering that this conversion is the one that you need to use. All right, so we will practice in class tomorrow. And you are not responsible for example 5 either.